Okay, in this video, I want to give you some tips about how to graph piecewise functions. Now, just a quick reminder that a piecewise function, that first part of the function, pretty much is only going to work when you have an x value less than 1. The last part of the function is only going to work when you have an x value equal to 1 or bigger than 1. So on a graph, that translates into an x value less than 1. Right here is actually 1. That's everything to the left of 1, and the other one's everything to the right of 1. So here's a tip on how to graph these things on paper. First off, 3x plus 1, we know what that graph looks like. That crosses at 1, has a y-intercept of 1, and has a slope of 3. And what I'm going to do is some of these points might be on our graph, some of them's not going to be. Because, again, reminder that we're only going to graph that portion of the graph everywhere to the left of 1. So we find 1. And notice I've got an open circle there, and I'm only going to start there, and I'm going to graph everything to the left of 1. And I'm going to go ahead and fill in those dots since I actually used them. Any dot that I didn't use, I'm just going to erase. Also, if it's less than and not or equal to, open circle. Okay, everything else is filled in. The second part of our graph is y equals x squared plus 3. I'm actually going to do that in a different color here. So 1, 2, 3, that's a parabola that's been shifted up 3 units. And I can use my 1, 3, 5, 7 pattern, as seen in my other videos if you'd like to watch, to actually graph that. Now, we're only going to graph this to the right of our value of 1. Again, imagine like a vertical line right here that extends the entire graph. And we're only going to graph that to the right. And notice since it says or equal to, I am going to shade in that dot at 1. I'm going to shade in this dot that I used, and that's the only portion of the parabola that I used. So I'm going to erase these other parts, and there's your graph. So you have a line everywhere to the left of 1. You have a parabola everywhere to the right of 1. Okay, let's try one more. So we're going to graph a parabola everywhere to the, let's get back on my pen, everywhere to the left of 0. Between 0 and 2 is what that means. I call that a sandwich. Between 0 and 2, we're going to graph that line. And then we have a constant graph everywhere bigger than 2. So let's start with x squared minus 1. And I'm actually going to graph the entire graph. There's your minus 1. And you can plug in points to find these if you want to. Again, I'm using my 1, 3, 5, 7 pattern. So therefore, that portion of the graph, though, is only going to be to the left of 0. So we're going to find 0, which is actually just your y-axis right there. So we're going to use, for sure, that point. That point's to the left of 0. Now, do I fill in or do I not fill in there? Well, since it's less than 0, we don't fill it in. And every point that I didn't use, I'm going to erase. I'm just going to keep the same color here. 2x minus 1. So that's going to be crosses at minus 1, has a slope of 2. So it's going to look something like that. And we're only going to graph that from 0 over to 2. So that'd be from here to here. So definitely using that point. Since it's or equal to on both sides, we're going to shade in the starting point all the way to the finish point. And those points that I didn't use, again, you can get rid of. So we have our line portion now. And then we're going to graph a constant function. Y equals 3 is a function that looks like this. We go up 3 units, and it's pretty much we're just plotting all of these dots that's up 3 units. Now, I did all those points just to prove a point, but we're only going to graph that greater than 2. So that's going to be only this portion of the graph. So you can fill in these dots if you'd like to. The rest of them we're going to erase. And there's what your piecewise function looks like. You have, again, the parabola, then you have a line, and then you have this other line, which is a constant function. So that's what that piecewise function would look like.